We are now going into Chapter 10 and Section 10.1, and that is covering radical expressions, functions, and models. So this is going to be Section 10.1, and basically this is really going to cover radical expressions. So we're going to look at today are a few key differences and some of the work you may have done in the past versus what we're going to look for in terms of answers and simplifying things that are raised to exponents and roots. So just for a few simple questions, recalling some of the things you may have learned when you were in middle school or high school, you may be asked to find the square root of 49. No radical, just identify all the possible square roots of this. And most people would say, okay, well, 7 is a square root of 49, and negative 7 is also a square root of 49. Why is that the case? Because if we take 7 times 7, that's going to give us 49. If we take negative 7 times negative 7, that's also going to produce 49 for us. Okay, so that's a little different than what you may be asked to do, like in question 17, where they pose the same problem. And here we're told to just simplify. So here we're asked to be given the square root of 49. Now, as a matter of math notation, a lot of times when you are in school, you're often told to find this as both positive 7 and negative 7. Reality, when you have something under a square root, at this point, we can only identify the answer to this as positive 7. This is one of those math identity things that is a bit long to explain. This is one of those things I'm going to have to simply ask you to take my word for and go forward. We'll take a look at when this is done a little differently. If we're solving for a variable and we have to take the square root of both sides, then we can encounter the negative. But if we're being asked to simplify something, we only express the positive value of it. This is further compounded a little more if we include a variable in this. So let's say, for example, and I'll go ahead and throw the example 39 here. Suppose I'm asked to find the square root of 64x squared. So the square root of 64 is going to be 8. The square root of x squared is going to be x. However, because we cannot have anything negative come out of this, we need to surround this in absolute values. And we can write it like this as the absolute value of 8 radical x, or I can rewrite this as 8 times the absolute value of x. Either forms are both equivalent and both forms are acceptable. But when there is a variable involved, this is when it necessitates that when we're using a radical symbol and we're being asked to simplify, that we need to use an absolute value. So what are the distinctions here going forward? If we're asked to just identify the square root of a number, we can identify both positive and negative values. If we are asked to simplify a value under a radical, we can only give the positive value of it. If we are given an expression that has a variable in it and we're asked to take the square root, then we need to use absolute value symbols, if not around the expression in its entirety, at least around this. Now, word of caution, I would probably choose this form because we're multiplying 8 times the absolute value of x. That's why we can separate here 8 times the absolute value of x. If you have the absolute value of x plus 3, you can't pull the plus 3 out and leave the x in. So I would err on the side of caution and express your answers in this way. So most of the work that we're going to do today is not going to be terribly difficult if you are familiar with how to take the square root and the cube root of things. If you are unfamiliar with that, then you may have to relearn some of this. But the big distinction usually involves unteaching some of the things that you may not have been taught properly when you were in high school. So let's go ahead and do some sample problems, but I'm going to keep referring back to this. If we're looking for just the square root of a number, no radical involved, we use plus or minus the answer. If we're looking for the square root of a number with a radical involved, no equation, just asked to simplify, we can only give the positive answer. If we have to take the square root of a term where there is a variable involved, then we have to use the absolute value symbol for it. I know I've said it a few times, but it's an important message you're going to keep hearing me say as we go forward in this section. So let's continue. So suppose I were being asked, like in question 11 or question 15, what is the square root of, give me all the square roots of 144, give me all the square roots of 900. Well, I know that 12 times 12 is 144, and I also know that negative 12 times negative 12 is 144. For 900, I know that the 1 square root of this is 30, because 30 times 30 is 900. I also know that negative 30 times negative 30 will also equal 900. So this is fine. Let's take a look at a few other expressions, though, and then take a look at a few of the tricks that are involved with that. So I want to take a look at 4 problems just to highlight a few examples here. We'll start first with question 18, and that's the square root of 144. So remember, we're looking at the square root of a number using the radical symbol now. And because we're only using the radical symbol, or we're using the radical symbol, we can only write this answer as 12. So what kind of tricks do they like to throw at you with this? So one trick they like to do is they may take a value, like in question 19, they throw a negative on the outside, and they say, okay, well, what's the square root, or what's the value of negative the square root of 16? Well, we know that the square root of 16, we can only express this as 4. But the negative is not under the square root, so we include that out here, and we get a value of negative 4, and only negative 4. So we cannot consider positive 4 here. The negative essentially takes this 4 and negates it, thus giving us this answer. Now let's take a look at a few other variations of this. So let's say, for example, we have a question like 23. And this is going to be written as negative radical 16 over 81. So what I'm going to do is I'm going to go ahead and I'm going to put the negative out here, and I'm going to write radical 16 over 81 on the inside. Well, the square root of 16, that's going to be equal to 4. The square root of 81 is going to be equal to 9. And now I'm going to bring the negative next to it to get negative 4 over 9. And that is the only answer that will come out of that radical. Another example of this may also involve something like a decimal, as in the question 26. If I have the square root of 0.36 or 36 hundredths, most students will usually say, well, the square root of that is going to be positive 0.06. But that's not true. And if you don't believe me, please go ahead and check it on your calculator. Because the way we get 0.36 is to multiply 0.6 times 0.6, and that will give us a value of 0.36. So the square root of this is actually equal to 0.6. So you may be asked to do this with whole numbers. You may be asked to do this with fractions. You may be asked to do this with decimals. So be careful of what you're doing when you're taking a square root. Bear in mind that when you have the radical symbol involved, you can only generate a positive number out of it if there's a number underneath. And if you have a negative on the outside, that negative is probably not going to go anywhere, at least not with the square root. So going forward, we'll take a look at some of the questions in this lesson. So we have now question 39. And here is where we begin to take the square root of items that now contain variables. Actually, we did 39. So I'm going to go ahead to question number 40. And this is going to be the square root of 25t to the second. So remember, we can only bring positive things out of this, and now a variable is involved. And because a variable is involved, I'm going to need to get whatever root I get out of this and put it in an absolute value symbol. The square root of 25 is going to be 5. The square root of t squared is going to be t. And now that is going to be done. So everything I've talked about up to this point has been about square roots. There's going to be a little difference coming up later, which we'll discuss at that time, but this is not an absolute rule that every time a radical is involved that everything is always going to come out positive. For square roots, that's absolutely true, but not in every single little instance here. So let's go ahead and take a look at question number 41, and let's see what the outcome of this is. So we have the square root of the quantity of negative 4b squared. So what we've got here is a quantity that's already being squared under a radical. So essentially what happens with this is the following. Let's take a look at maybe a simpler example to highlight this. If I have, let's say, just 4 squared under a radical, well, 4 squared is equal to 16. If I take the square root of 16, that's going to give me 4. So essentially, I get what I have in here at the end. Why does that happen? Because the square and the square root basically undo each other. So now you could do all the steps involved, but sometimes you lose the essence of the work, and it's easier to just kind of reduce these. So if you've got a square and you've got a square root, all we're going to do is take the quantity that's inside, namely negative 4b, and we're going to contain that in the absolute value and simply eliminate the square and the square root. As I mentioned, they outdo each other. Now, you could write it like this, but if you were to bring the negative 4 outside the absolute value, remember, you can have a negative inside an absolute value, but this negative 4 cannot come outside as a negative. Now, the only reason you can bring it out in this particular case is because the negative 4 is multiplying the b. So you could, if you wanted to write this, as 4 times the absolute value of b, because the absolute value is going to have this come out positive. Again, I recommend leaving the answer in this form, as it is mathematically correct, and you risk less of a chance of error. However, when you're doing your work on MyMathLab, they may look for an answer in this form. So let's go ahead to question number 43. Give you another example of this property. We have radical the quantity of 8 minus t squared. So again, we have the square and the square root outdoing each other. And so what I'm going to do is whatever inside the parentheses, I'm going to write out here. And because now we've got a variable involved, we need to take the whole expression and leave it in the absolute value. Because now we have 8 being added to the value of negative t, we can't bring this out. So this is as simple as this is going to get. Let's take a look at another variation that may require just a little more work. So question number 45. I have the value of y squared plus 16y plus 64. So you look at this and wonder, how am I going to possibly factor this? Well, that pestering factoring is going to come back now, because I can go ahead and rewrite this as y plus 8 times y plus 8. Once I write it as y plus 8 times y plus 8, I can write it as the quantity of y plus 8 squared. And when I take the square and the square root of this is going to give me the absolute value of y plus 8, and I'm done. But again, I have to include the y plus 8 and the absolute value symbol as part of my final answer. So what we're going to do now is begin to explore problems that have excuse me, that have other roots than square roots. So let's take a look. So let's say, for example, look at 49. We have negative the fourth root of 256. So you may not be real comfortable with your roots here, but we're looking for a number times itself times itself times itself is 256. Because it's even, that means that the root has to be even. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's not it. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. So the number inside of here is going to be a 4. But that negative is not going to go away. So here we're simply looking for the fourth root of a number. Now let's take a look at what happens when we have like a third root or a fifth root, because now we're going to begin to see some exceptions to this rule. 52. We we have negative the cube root of negative 1,000. Now, if you had a negative underneath, like a square root, a fourth root, these are answers that are not possible. We can't simplify those. Okay? And we'll see a few examples that won't be simplified in a bit. However, because this is a cube root, we're calculating what number multiplied by itself gets negative 1,000. So that would be negative 10 times negative 10 times negative 10. 10 times 10 is 100, times 10 is 1,000. A negative times a negative is positive. A positive times a negative is negative. So yeah, so we can simplify the cube root of negative 1,000 to be negative 10. And that's the only root for the cube root of negative 1,000. We still have this negative that's on the outside of this work here. So when I distribute that through, that's going to give me a final answer of 10. And that is the final answer to question number 52. Let's consider another problem, 54. If I have the fifth root of negative 1 over 32, well, and again, no negative on the outside, but there's a negative on the inside. Is there a number that we can multiply that number of times to get this? Well, we know that the fifth root of 1, 1 times 1 times 1 times 1 times 1 should be 1. That's 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's going to be 2. So the fifth root of 32 is 2. And the only way we get a negative here is if this result is negative. So the fifth root of negative 1 over 32 is negative 1/2. Nothing else to do at this point. We have this problem. No variable, no absolute value necessary. As a matter of fact, let's go ahead and take a look at another problem, 57. We have the ninth root of t to the ninth. So we're not going to go real deep into how all the properties of radicals work, but in this case here, I can write this simply as t. There is no absolute value necessary for this. And the reason that is because we have an odd number root. Because we can still have some negative value that occurs under here, like we have the cube root of negative 1,000, or the fifth root of negative 1 over 32. So we can have a negative number come from here, therefore we don't need to put an absolute value symbol. However, if you had a problem like 56, where we have the eighth root of y to the eighth, the value we have to generate out of this is going to be the absolute value of y, because this is an even number root. You will see examples in your homework for these questions that should help clarify the work that you're doing for this. Let's take a look now at number 60. This is going to be the fourth root of 8y to the fourth. This quantity has to be in parentheses so you understand that it's 8 and y. That's raised to the fourth. The fourth root and the fourth exponent both undo each other, much like the square and the square rooting did before. So this is going to give us the value, or absolute value, of 8y. If this were like a fifth root, then no absolute value symbol would be necessary. Let's take a look at another value here. This is going to be 67. Here's the square root of negative 25. There is no real number times itself that's going to give you a negative 25. If you multiply negative 5 times negative 5, that will be 25. If you multiply positive 5 times positive 5, that will be 25. You can multiply negative 5 times positive 5, but the square root only identifies the number times itself, not one of the opposite sign. So for this one, this cannot be simplified. So beware of questions like this. So that concludes this portion of the lesson here. There'll be one more brief lesson following.